Dear Professor and classmates, good afternoon. I'm very glad to be here for this interview. My name is Wentao, and I'm a PhD student from the Institute of Architecture and Civil Engineering, Ural University. I'm going to share a scientific article published in the Applied Energy, and it is an international top journal in the field of building, heating, and solar energy utilization. The topic of this scientific article is design and thermal performance evaluation of a new solar air collector with comprehensive consideration of 5 factors of phase-changing materials and comperform compilation. In the scientific article, our research process is merely divided into 4 parts, and 3 research methods are used. Number 1, introduction. Number 2, methodology. Number 3, research and discourse. Number 4, conclusion. Look at number 1, introduction. First of all, in this scientific article, in order to solve the problem for low thermoconductivity of phase-changing materials and improve the thermal performance of the solar air collector with phase-changing materials, and meeting the requirements of building users. We designed a new model of solar air collector with phase-changing materials and from compilation based on the solar air collector with phase-changing materials. Then, the key solar air collector models are compared and tested. It is expected to obtain the influence factor on the thermal performance of solar air collector and a new model of the solar air collector with high quality and meeting the requirements of building users. Look here. This article adopts the comparative analysis method in the introduction. We compared and analyzed a lot of scientific literature on the solar air collector with phase-changing materials and couple form, and conclude that it has greater research potential for the solar air collector with phase-changing materials model. In addition, this research topic has not been studied at all. This factor account for the innovation and the novelty of this research topic. This research topic will help to obtain the influence factors on the thermal performance of the solar air collector and new models of the solar air collector with high quality and meeting the requirements of building users. Look at methodology. In the second part, this article adopts the comparative test method. We built the solar air collector with phase-changing materials model and the solar air collector with phase-changing materials and couple from combination to carry out comparative tests. In addition, the article uses the temperature test, window speed test, solar energy test, heat flow test to obtain the experimental data of two solar air collector models. Look here. Look at research and discourse. In the third part, here is results and discourse. This article adopts comparative analysis and evaluation method. We compared, analyzed, and evaluated the solar plate temperature, phase-changing materials temperature, outlet temperature, useful energy, heat flow, and heat efficiency of two solar air collector models. Look here. Finally, here is a conclusion. The conclusion shows that compared with the solar air collector with phase-changing materials, the solar air collector with phase-changing materials and couple from combination improved the temperature region, heat storage ability, heat release efficiency, heat release time, heat peak magnitude ability, and heat efficiency of the solar air collector. Look here, conclusion. We should solve the problem for low thermal conductivity of phase-changing materials and improve the thermal performance of the solar air collector with phase-changing materials and meeting the requirements of building users. Okay, that's all. Thank you for your listening.